Okay, so today did not go as I was initially anticipating. I thought that we were going to get a lot more done on the project, but then got hit by problem after problem after problem, and that kind of revealed that there was a significant or multiple significant gaps in my understanding of some of the concepts that I think are probably fairly important within software engineering. So in today's video, what I'm going to do, or I guess this video since I did multiple videos today, but in this video, what I want to do is more of an engineering investigation type of video where I am going to try to identify, well, what concepts did I actually struggle with and wrestle with those concepts, try to understand what is actually going on, what are these things which I was running into today. That way, next time I come into one of these problems, I'll be like, okay, now I have more of a framework by which I know what's going on. And something that I found very true with engineering, or something that I found out with engineering is this. If you have one problem, you can deal with it. If you have two problems together, it's significantly more difficult. If you have multiple like problems all on the on trying to accomplish one task and you have multiple things that you don't understand, it is significantly more difficult. And the reason is because you'll change one variable and then you'll try to the way normal way of troubleshooting, you change one variable and then see the response, right? You change one thing and then see, oh, how does it act now? And then you say, oh, that one variable that I changed did this effect. And then you're able to kind of figure out, oh, okay, well, I found the thing that I don't quite understand, and you're able to move that way. But if you have multiple things together, you change one thing, but you don't even understand what the output is. Or maybe it was some other problem and you're going down this one. So that's something that I've found is fairly difficult with engineering, and this applies to both electrical and software. So, yeah, anyways, in today's video, or the video right now, what I'm going to do is I'm going to try to look towards those concepts that I was saying, I don't quite understand what's going on, and try to find out more about those so that next time I will have a much better ability to say, okay, well, at least I know what's going on, and then I can probably figure it out, and we won't have a repeat of what happened today. So, one of the I asked, can you summarize? So I was troubleshooting with Copilot here, and I said, can you summarize the problems which I was experiencing today and today into concepts that I might be missing? And this is the only one that I think is valid. I have a lot of other concepts that I am confused about, but I think that Copilot missed it because we were doing a lot. We were doing Copilot here, we were doing Agentic Copilot there, and then we were also doing Google Gemini. So there was multiple things that I was trying to use to solve this issue which I was experiencing today. So one of the things, okay, let me think about like even what I was having difficulty with. So I had my GitHub account and I was trying to push this, not necessarily this code specifically, um, but I was trying to push, I created this end-to-end test, okay, and I pushed it to GitHub. This workflows end-to-end test triggers this end-to-end test script, okay? And then I was getting an error. And the error specifically was it was unable to get this service, no, not this services, sorry, this shared. It didn't like, it was didn't know about this context or this folder here. Now I've since put stuff in there, which is another thing that I did. So that's kind of what I'm talking about. I've done multiple different things, and now I'm trying to uh, segregate them and say, okay, well, I did this thing, which is I moved files into a previously empty folder. Okay, but then I also changed a Docker file. Then I changed the Docker Compose file. Then I had to change the using the namespace of these, and then I was changing the apparent. I oh right, I also created a project here, a .NET project here. So created I completely forgot about that. I created a project in this shared directory. I moved these out of models. They used to be in models, but now models is empty. And then I also needed to update the SLN, the solution for the overarching project. I changed the tests to be able to recognize, right? I did this project reference here, this one, to have shared. Okay. So this is kind of what I'm experiencing right now. And I think I did 3 videos today, 2 or 3 videos, and I was just like 3 videos, and I was just like, each time running into an error, and I just got more and more desperate. I was trying more and more things, and then eventually something worked, and all of my unit tests passed, and my end-to-end test passed, and I was just like, oh, okay, well, awesome, wonderful. I'm so happy that it passed, but now why? And that's why I'm trying to figure out, okay, well, what is the actual cause? So one thing that I'm looking at right now is, okay, this right here, project reference include, and then I said that I'm doing this right here. And remember that I just said that I forgot that I created a new project in here? Yeah, I forgot about that. And so I was so confused about why I needed this when I initially did it, but I just copy and pasted it because I was, again, I at that point I was kind of over it. I was just like, okay, fine. It says that I need it, go. And then, so now with this extra context, it actually makes a little bit more sense because what I'm able to say is what this is doing is it is a C# project, this one right here, and I am telling this test project of this C# project's existence. Now, I need to clarify that and figure out where and who's talking to what and who is the orchestrator of this. And uh, yeah, so we're going to have a lot of questions on this. But first, before I do that, I do want to look at this so that I don't lose this one. So, first thing is build context versus file path in Docker. So your Docker file tried to copy. Okay, so let's look at my Docker file. So we are talking about this Docker file. And where's the line that it didn't like? This one. So your Docker file tried to copy this. Copy shared or source shared. This is my local right here. And I'm trying to copy it to this location. Okay? But Docker said, even though the folder does exist in your repo, the real concept. Oh, it said this right here, even though it did exist in my repo. Docker can only see files inside the build context. Okay, so I don't know what build context means. We're going to find that out. There was some analogy about a house. I forget what was. I think it was actually Gemini that said that, but it was talking about a house. Okay, so Docker can only see files inside of your build context. If your build context is too narrow, anything outside that folder is invisible. Okay, so I like Gemini's explanation of that, where it was talking about a the house. So locally, your build context may have been correct, but in CI, your context may be different. So the same Docker file behaves differently in multiple environments. Okay, so I am actually going to go and instead of asking this one, I'm going to ask Gemini. Okay. Does it have my old ones? No. Okay, I would need to sign in. Okay, never mind. I was going to ask it to sum up or summarize up my previous conversation with it so that I could find out what it thought my gaps in knowledge were, but apparently we don't have that context anymore. Okay, so let's do this. So in Docker, the distribution or the distinction between build context and file paths is the most common source of file not found errors. Okay, so the difference between these two things, build context and file paths. What that is, I don't know yet, but it is a very common problem which results in file not found errors. So if I see a file not found error, I might be trying to identify these concepts. Okay. Think of the build context as a security fence. Build context as a security fence around your files. Docker cannot see or touch anything outside of it. Okay, so security fence around my files. Okay. That is the build context. So it can't go outside. It can only go inside of its context. Okay, fine. That makes sense. When you run docker build dot, is that from the Docker compose or the Docker file? So when you run docker build, the dot is the build context. So let's look at my Docker file here. Okay. Well, I don't, okay, so it would be the Docker compose. So I have my Docker compose and I have bid engine here. I have context of dot. And then here's the Docker file. Okay. It tells Docker CLI to pack up everything in the current directory and send it to Docker daemon, the engine that actually builds the image. Okay, so first step is when I think that this is more talking about the command line interface, like when I do docker build from the terminal myself, but I'm using a Docker compose file and telling it the context of dot of current directory. So then what happens is it packs everything up in the current directory and sends it to the Docker daemon. So packs everything up. How? And sends it to the Docker daemon. So there's a daemon running that will build the image. Okay, fine. And now I have an image. Where is the image stored? I think, okay. Docker desktop manages that, I think. The rule, your Docker file can only access files that were sent in the package. Okay. The security boundary, even if you use two dots up in a copy command, Docker will block it if it tries to go above the root of the build context. Okay, I'm starting to see kind of what's going on. So I need to give kind of a higher level context so that I can add all of the files and that Docker is able to access all of those different files. Okay. The file paths, host versus image. And we're obviously going to have a lot of follow up questions on this, but I'm just trying to get an overview of this concept right now. And then we'll ask follow up questions here. And then we're going to try to identify what were the other threads of uh, not communication, but concepts that I missed. Okay, file paths, host versus image. In Dockerfile, you deal with two different worlds of file paths. The copy and add commands act as bridges between them, okay? So now there's add, and I know that I was adding to a solution at, oh, and then the GitHub ignore. There was also, we have the dot ignore and or dot git ignore and then dot docker ignore, and we created a new docker ignore. So yeah, this is why I say that there's a lot of stuff that was tried today and changed. Okay, so path, the source path, the file of your computer, yeah, relative to the build context root. Build context root, that's the the root that I give context to. That's the dot here. Now I need to know what that means in context or in relationship to a Docker compose file. Okay. Destination, where the file goes inside of the container. Absolute or relative to work directory. Okay. So let's go with an example. So imagine your project looks like this. I have my project, and I have app with my main.py. Okay, so we're now in Python land, but that's fine. I have data with a configuration file and my Docker file. Okay. If you run docker build and then -t my app, then dot from my project, okay? So we've given the context of dot, right? So that means that Docker has ability to look at everything in this directory, so everything in here. But it can't go outside. So from the folder, correct, copy app main, goes into app, goes into main, and then source, Docker looks inside the context for the app folder. Yep. Wrong. Copy, and then from user, I see. Okay, so I can't do an absolute path, right? Relative, yep. Okay, so I can't do an absolute path because it doesn't have access to that context. Docker does not have access to that context. Okay, and then this destination, right? That's what it was called, destination path. Yep, so it's the same as like terminal commands. Okay, so the destination is absolute host paths do not work. Docker only knows the context. Yeah, the context meaning the root context location. Okay, so wrong is go up one level and get the other project and put it into source. Okay. Okay, so I think I see what that is saying. And now what I'm thinking is, okay, so I have, let's look at my project and see what might have been causing this issue. So I have I'm going to close tests because I don't need tests right now. I'm going to look at source, and I am going to say bitengine. And then in bitengine, I have my Docker file right there. Okay. So now inside of my Docker file, I am trying to copy this one, source, which is one level up, but I believe it should have the context, and we need to verify that with the compose. Okay, so one layer up, shared here. I'm trying to copy that directory into this directory, which is in Docker. So to the Docker image. And this was failing because it was unable to find that directory, right? I believe so. Okay. So far I don't think we found that issue because it seems now, but now at least I have a conception. Okay, so I'm starting to understand what it's meaning by context. And now, okay, so we are still within the context because I have my Docker compose, which is here, and I give the context dot, and my Docker compose is on the add simulator here, which has source, which has shared. Okay. So now the argument at the end of the build command, build dot, that's the context, yeah. So scope, global defines the entire set of available files. Limitations is determines build speed. Okay, optimization, controlled via docker ignore to exclude heavy files. So we can exclude certain files here, controlled by work directory. Okay, so now let's ask our follow-up questions. So number one is going to be, let's come back up here. If I have a Docker compose file and two Docker files in separate projects under the, I'm just going to say multiple Docker files inside under the root. Here is my file structure. Okay, so I'm going to give it my file structure, just show it new terminal. So tree minus L, and we'll go 4 like that. So give it the file. Oh, okay. Are we? Okay, here. I was like, did we go too much or what? Okay. So here's the file structure. Then here's my bid engine Docker file or section. How does this operation work? Okay. What context does it have? Let's see. Also, Another question that I'm getting into a lot is, when does a build actually occur? When does a build actually occur? Meaning the project gets recompiled or the Docker file gets hit. Can you explain the high level overview of the concepts which I am employing when I use my Docker Compose? Okay. I don't know if that was the perfect question, but hopefully it will get us a little bit in the right direction, and we might be able to ask some follow-up questions. Okay, so root context strategy. That's what I'm trying to do, okay? Because your bit engine needs access to source shared, okay? Which is outside its own directory. You've correctly set the context to the root. Okay, yes, that. See, now it kind of makes sense. Now I'm like, okay, yeah, I did. I knew it even before I asked the question now. Whereas previously I was very much lost. How does the context work in your setup? When you define context dot in your Docker Compose, you're telling Docker take every single file in the add simulator root folder and send it to the Docker engine. The view, even though the Docker file sits inside source bit engine, it can see source shared. Okay, that kind of makes sense because both are inside the boundary of root. Okay. The path inside your Docker file, the path inside of my Docker file, this one, okay. Oh, my neck. Copy source bitengine cs proj. Is it talking about how to build it? Okay. When does the build actually occur? The project gets recompiled and the Docker file is hit under these specific conditions. Initial run. The first time you run Docker Compose up, okay? But that's only the first time. Then manual trigger. When you run Docker Compose build or Docker Compose up with the two builds. Okay. So I'm wondering if this also could have been a problem, is that I was doing like, I wasn't triggering a build, possibly. I've run into that issue so many times. I need to look into that as well then. Missing image. If the image specified or generated doesn't exist. Crucial note, the Docker Compose does not automatically rebuild just because you've changed a line of code in program.cs. It has no file watcher. If you make a code change, you must run Docker Compose up build to trigger the recompilation of the Docker container. Okay. So what this is telling me is I should have thought about this as well. Is okay. So I'm gonna do a follow-up question and test my knowledge. I want to see if my conceptual knowledge is accurate. If I have a Docker compose and a Docker file. Okay, if I have this set up right here, then, but what was the error I was experiencing? It still should be able to see that source, right? Yeah, okay. Okay, so I need to start making all the notes of all of the different things that are going on in my head, trying to understand. Because if I make a change, and I'm trying to reanalyze like which changes I made. If I make a change which is technically I documented everything. I did the YouTube video of it, so it's like okay, well technically I can just go back and look at it. Um, cool. But if I made a change to my Docker file, okay, I'm not gonna say this. Um, if I have my Docker compose and my Docker file, then I make a change to my Docker file, does this, what happens in this situation? What happens in this situation? Okay. That's follow-up question number 1. Follow-up question number 2 is going to be, in the case where I am pushing my code to GitHub and then there is an end-to-end action which is being done, how does Docker work in this context, in this situation? Okay, I don't want to use context because that has a very specific word. Number 3, can you walk me through what happens when I do a Docker compose build? What changes and how are all of those things kept track of? Alright, so high-level concepts. Multi-project contextual build. So in .NET, your bid engine is standard. Okay, bid engine is standard. Since bidengine.csproj likely references shared csproj. So we don't know what referencing actually does. Remember, that's how we started off the video, I believe. It was this one. And I said, I don't really know what this project reference actually does. I don't understand why we would need this or how this interacts. I don't know who's the .NET runtime has to be taken care of, or that's has to be who we're telling it about, but I don't know how this is operating. Anyways, so a Docker file located inside a bitengine folder would fail if the context was just that folder. It wouldn't be able to find the shared library, okay? Let me read that again. In .NET, your bit engine is the standard. Since bitengine csproj likely references shared csproj, a Docker file located inside of the bitengine folder would fail if the context was just that folder. It would not be able to find the shared library. By setting the context to root, you allow this. Okay? Layered caching. Inside your Docker file, you are likely using something like this. Copy the solution, copy source bitengine, .NET, restore. Docker caches each step. If you change the code in one of my big controllers, but don't change my project files, Docker will skip the .NET restore and start building the code copy step, making the build much faster. Layered caching. Okay. For a layered caching, does this mean that Docker compose, what was it, build? This is going to be a important one for me to make sure that I memorize. Docker compose yeah, it's just Docker compose build or Docker compose up build. Okay, I was wondering if it was the dash. Will still not reflect my changes in code. Okay. So changing the Docker file. If you change the Docker file, add a new run command or change the base image, but do not change your source code. Okay. What is this situation? Change my Docker file. So my Docker file is changed, like I added a new run command, but there was no change to my actual source code. The up behavior, if you just run docker compose up, Docker looks for the existing image on my machine. Since the image name hasn't changed, it will usually start the old container and doesn't know how the Docker file changed unless you tell it to check. Okay. And then Docker build. If you run docker compose up build, Docker will see the change in the Docker file. It will invalidate the cache at the line you changed and rebuild every layer from that point down, okay? But the other layers above it are still there. GitHub Actions. In a GitHub action, the CI/CD, right? The environment is ephemeral. So what does ephemeral mean? It means a fresh computer every time. Okay, that makes sense. Docker build. The runner executes Docker compose build. Since it's a new machine. Okay, that makes sense. That makes sense. Because it's ephemeral, it's a new machine. Every single time it is running, it is that initial time. Since it's a new machine, it has no cache. It builds your image from scratch unless you use cache actions to pull previous layers from GitHub stores. Okay, the test. Once built, it runs Docker Compose up. Your app starts in the runner's memory. End-to-end tool. A tool like Cypress or Playwright runs against localhost, my bit engine, okay? So then, teardown. The runner is wiped clean. Your Docker images are not saved unless you explicitly push them into a registry like Docker Hub or GitHub packages. Okay. So, Docker Compose build. What happens in this situation? When you run this command, Docker performs a check and diff process. Sending the context, the CLI packs up the root folder, the dot, and sends it to Docker builder, okay? Then we have the layer comparison. Docker goes through my Docker file line by line. It calculates a hash, which means a unique fingerprint. Okay, yeah, we got that, of each instruction. For run commands, it checks the text of the command changed. So this seems like it does check both the... So here... Okay. Docker keeps an internal database of these hashes. If a hash matches a layer it already has on disk, it says cached and skips the work, okay? A new image ID is generated. Docker Compose then updates its internal link so that the service bit engine now points to the new ID instead of the old one, okay? So would this have led to my problem that I was experiencing today? I don't think so, and the reason I'm saying that is because when I did even if I didn't save or create a new image, I was pushing my code up to Docker or to GitHub, and GitHub initiates a new build process every single time because it's the first time it's seen it. And I was failing on GitHub, which means that it should be compiling all of my code and not caching things. Okay, so does this mean code changes won't be reflected? No, quite the opposite. Layered caching is designed to be smart enough to know exactly when your code changes. However, order matters. Look at these two examples. So copy all of this and then run Docker restore, Docker build. Sees a code change here, cache is broken, okay? So this one, we copy over the project, restore, only the compilation happens, okay? In the right way, if you change a file in big controller, Docker uses the cache dotnet restore layer because the csproj files are identical. It only starts doing real work at the copy step, okay? So what do these two lines actually do? They separate dependencies from the source code. In .NET, your CSproj file lists all the NuGet packages. Okay, yeah. Downloading these packages, .NET Restore is usually the slowest part of the build. Okay. So copy over the source bit engine, anything that ends in CSproj. Okay. The action. This tells Docker to look into your build context, the root folder, find the project inside of source bit engine, and copy only the files into the temporary container where the build is happening. So the working directory, right? The goal, we want to give Docker the shopping list. So the CSproj without giving the groceries, the actual CS codes yet, okay? Then .NET Restore, the action, this command looks at the CSproj file you just copied and goes out to the internet, downloads all of those required libraries. Okay, so .NET Restore does the libraries. The magic of caching, Docker creates a layer on your hard drive for this step. Scenario A, code changes. Okay, so now I'm starting to see why that means that I wouldn't need to. I wouldn't. Just because one of my code changes within one of my C# files, why I wouldn't need to do the restore part. Okay. So if you did copy followed by .NET Restore, any change to a comment in your code would invalidate the cache. Docker would think the file has changed. I must run the restore. It would be forced to wait to download all of the NuGet packages. I see. How it looks in your specific project. Because you have a shared project in Dockerfile, Dockerfile actually needs a bit more complex. Needs to be a bit more complex to take advantage of it. It should look like this. So copy all of the project files first. Let's see. Where is it? Here it is. So the working directory is build, okay? Then we copy over the project, source bit engine, copy over shared, then run the restore. CSproj, this CSproj, and then restore. Now copy the rest of the source. Run docker build. Okay. What do you think of my current bid engine Docker file. Go. Okay, because you're using a single shared project, you've run into the classic Docker dilemma. How do I restore dependencies without copying all the source code? Okay. Oh man. I was not expecting to get into this today. Build stage. Excellent. Using as builder and then switching to ASP.NET runtime keeps your final image tiny. No SDK included. Base image. You're using .NET 9, which is the latest okay. By copying the entire source shared folder before the restore, any changes to a CS file in shared will force a full NuGet download. Yeah, so that's what I was starting to come to the realization of is, hold on, isn't this what I'm doing here? The caching problem. Look closely at these two lines in your file. This copies everything and then it does a restore, okay? What happens if you change a single comment in a class inside of shared project? Docker sees the source shared has changed. It invalidates the cache and reruns .NET restore. Okay. You shouldn't have to wait to get NuGet packages just because you changed a line of code. Now, I'm very nervous about doing this because I just spent the entire day debugging something and it's working right now. So I'm actually just gonna look at this and not change anything. So as builder, okay, builder. So we get the CS project here and put it into shared there. Okay, so one follow-up question is, why does my Docker container for bid engine need to have the project file of the other project, the shared one? Okay, so restore. This perfectly caches, and then we can copy over all of the other files. So my second question is, when you did the two stages in your example Docker file, after these lines, we will put both csproj files into we'll put shared into the Docker image path or folder of source shared, okay? Then after these two lines, we will copy over everything overwriting original shared CS proj file. Okay, now number 4 is going to be, I thought I had a question, I can't remember what it is. Okay, so does this mean that when I have a running container from that image, I am now allowed to access a path called source shared? If so, how do I access it in the Docker container? Okay. So publish here. Okay. Oh yeah, what is working directory? Number 5, what is like directory? Okay. So, we lost that. Why does Bitengine need the shared project file? So, in .NET, a project reference is not just a link, it's a dependency that must be resolved at compile time, okay? When the compiler looks at Bitengine CS proj, it sees a link to this other project. If that file isn't present in the Docker environment, okay, the compiler will throw an error saying it cannot find the referenced project, okay? Okay. Even though you're building the Bitengine image, you are technically building a mini solution inside of the image that anything, okay. So yes and no. Technically, yes, the second copy will copy all the files from the host and put it back into there. Docker logic doesn't mind overwriting a file with identical copy of itself. Okay, it's fine. So accessing shared in the running container. Actually, in your specific Docker file, you cannot access shared in the final running container. Here's why. You used a multi-stage build. Stage 1 builder, you compiled your code here. Published up says this takes only the finished compiled DLL files and puts them in the app. This means your final image only contains the finished binaries inside the app folder, the source code, and the work directory. So this is just a change directory command, but with 2 special powers: creation. If app doesn't exist, it's created; persistence. Every command that follows copy run or entry point will execute inside that folder. Alright. So I think that definitely a lot of these Docker concepts are throwing me off. Also, the actual project, like how the C sharp projects are compiled and built and where they're looking for what, how they're associating things. The other thing which I'm having difficulty with is the solution, right? Okay. What was the other thing that I said that we needed to do? Was this. So this like tells us this is a dependency, so it's like a library. So if that reference is like a dependency, come on, then it means I am getting it can you explain how the entire startup process works, including the compilation of everything? I think I am having two issues. One is I have misunderstandings. I have understandings of Docker processes, and also don't understand how C sharp and .NET work to build and compile projects, and how different proj and the .NET runtime are in this process. Is it because I've only had like 2 or 3 cups of coffee today? I normally have like 4 or 5. I don't know. Well, I think it's also just because I've been troubleshooting so much today and just running into so many problems. I can't tell if that means that I've learned a lot or if it's just because I've been spinning my wheels. Like, if I've learned a lot, then awesome. That's wonderful. Um, for many developers, you are essentially coordinating 3 different systems: Docker file systems, the .NET SDK runtime, and the C Sharp compiler. Okay, so let's look at this. So the big 3: SDK, runtime, and CS proj. To understand the build, you have to understand the 3 roles of these things. My goodness, I can't even read. I might need to even come back to this because I feel like my brain is just shut off. Okay, Come on, you can do it. The big three: SDK, the runtime, and CS Proj. To understand the build, you have to understand the roles of these three things. SDK is the factory. This is the massive toolbox. It contains the compiler, the NuGet client, the Microsoft build engine. You only need this during the build phase. Okay? The runtime, this is the engine. This is a lightweight version of the SDK. It has no compiler. It cannot turn code into a program. It can only spin a DLL that has already been built, okay? CS Proj is the recipe. This file tells the SDK two things. Here are the ingredients I need from the internet, okay? Here's the other project dependencies. Yeah. The step-by-step compilation process. When you run Docker build, here is exactly what happens inside of the builder stage. Docker build, okay. Restoring dependencies. The SDK looks at my project file and sees a reference to this library that I created. The logic, I need to make sure that all the NuGet packages for both are downloaded, okay? Why both? Because shared here, this before running restore. Building the code. Now the SDK looks for your CS files. The logic, it turns C# text into the intermediate language. When the compiler builds, it sees you used a class called shared. It looks for shared DLL. Okay, so now I have the DLL. If it's not built yet, it builds shared and then links it, okay? The output is I have that DLL, the shared DLL, in a sitting in a bin folder. So now .NET publish. This is the most misunderstood step. The build just compiles, publish packages it. The logic, it gathers the build DLL and the shared DLL and every single NuGet DLL you downloaded and puts them into one flat folder, my app folder. A single folder that contains everything you need to run with no source code in sight, okay? How Docker bridges the gap. Your Docker file is essentially a scripted computer. Stage number one, the factory. You start with a computer that has the SDK installed. You bring the source code, run the factory, restore, build, publish, and create the app folder. The cut. Docker throws that computer away, keeps only the app folder. Docker starts a second tiny computer, only has the runtime. It copies app folder from the dead factory to the new one. So where is it copying? Maybe it's here. Oh, app here. So it's building, publishing everything to app, right? Maybe. Then it goes into the working, that thing that it just created, I think. And then it does .NET and then starts that DLL. Why shared project is special. In C# setup, when project A references project B, the compiler expects project B to be in a specific relative path, usually ... and then project B. When you are in Docker, if you only copied bitengine folder, the compiler would look at this and find empty space. By setting the build context to root and copying both uh, project folders onto the container, you are recreating the exact folder structure the compiler expects. Okay. And then if so, a helpful way to think about it, if you were a ship, or if you were to ship a car, the SDK is the factory that builds the car. The runtime is the gas and the road. Okay. You don't want to ship the entire factory to the customer. Okay, yeah. You just want to ship the car. Your Dockerfile builds the car in the factory, takes the car out, and puts it in a piece of road. Okay. Okay, I think I'm gonna rest on this a little bit. Um, yeah, I think I'm gonna rest on this, try to let it settle into my subconscious. Hopefully, I did learn something today. I'm not sure about that. But yeah, so thank you guys for watching. If you enjoyed it, subscribe, and we can go on this journey together. And my name is Timothy Lee Grant. See you soon.